Okay, so this is problem 30.13 from homework 9, and it states the loop in the figure is being pushed into the 0.10 Tesla magnetic field at the speed of 40 meters per second, and the resistance of the loop is 0.4 ohms. So for part A, they want us to calculate the magnitude of the current in the loop. So I've just drawn out the figure they've given to us. We have our current loop, we have our magnetic field pointing out of the page, our velocity going upwards, and then the length of the loop. And then I've just listed out all those values. So they've given us the magnetic field equal to 0.10 Teslas, the velocity equal to 40 meters per second, the resistance equal to 0.4 ohms, and then that length equal to 5 centimeters, which we need to remember to convert to meters, so 0.05 meters. And then, so the equation we want to use for that induced current is going to be just the velocity times the length times the magnetic field over the resistance. So we know that current is equal to the potential difference divided by the resistance, and that potential difference induced by the motion of the loop through the magnetic field is going to be equal to VLB. So we just plug that in as the potential difference, in other words, the motional EMF, and divide that by the resistance. So we have all those values, we just plug them in, and we get our current equal to 0.5 amps. And then for part B, they want us to figure out the direction of the current in the loop. So to figure out the direction, we just need to use the right-hand rule. So let's see if we have, we have velocity going up. We have the magnetic field pointing out, out of the page. And then, so our current has to be going to the right, at least at top here. So if it's going to the right here, then it's flowing clockwise. So the direction of our current is clockwise. And this all ties into what we're learning in chapter 30 with electromagnetic induction, also with motional EMF and induced currents. So I don't think there's really any other tricky parts to look out for other than just make sure you convert and do the right hand rule.